Did you know something about motion? If you don't know, then don't worry. I am Magar from International School. So today we are going to learn about motion. So what is motion first of all? Motion is a movement of an object that we will learn now in this lecture. There will be three lectures of this chapter. There will be three lectures of this chapter. This is lecture 1 in which we will learn basic like a speed, distance, velocity, displacement and acceleration. Okay, so let us start our lecture 1. So what we will learn first of all? First of all, we will see the physical quantities. Physical quantities. First of all, we will see the physical quantities. So what are the physical quantities? A physical quantity is that which can be measured. Okay, for example, we can take, this is the definition and example we can take mass, force, temperature, etc. Again, many things are there like acceleration, velocity, displacement, distance, again temperature, weight, mass. These many things are there in physical quantity. What is the physical quantity? Physical quantity is that which can be measured. So clear? So now we will learn about next. Write in your notebook this important point. So next we will learn about physical quantity. Next we will learn about types of physical quantity. There are two types of physical quantities, scalar and vector. Scalar quantity and vector quantity. Okay, there are two types of these. So there are two types. So now let us learn about scalar quantity. So what is included in scalar? Scalar means which can be measured. Sorry, scalar means no direction is required. Direction is required in the vector. Direction is required. So this is the main difference between scalar and vector. In scalar, direction is not required, and in vector, direction is much important. Without direction, the vector quantity don't have any value. But in scalar quantity, there is no need of direction. For example, in scalar, we can take mass. Mass we can take, again we can take distance, temperature, etc. And in vector we can take example force, acceleration, again we can take displacement, again we can take velocity. So these are the examples of vector and these are the examples of scalar. So note it down in your notebook, examples of scalar and vector. So what we learn here? Scalar means it don't have any direction and vector means it has the proper direction. It need a direction to measure it. In scalar quantities, there is a mass, distance, temperature we can take, and again in vector quantity, displacement we can take, force we can take, acceleration we can take, velocity we can take. So these are the example etc, because many example are there again. So now next what we will learn? We will learn next what is rest, what is motion. So first of all we will learn motion. So first of all, what is motion? An object is in a motion, and object is in a an object is in motion when it change its position from initial to final position. So this is the definition of motion. You can take, this is the definition of motion. This is the definition of motion. An object is in a motion when it change its position from initial to final position. So this is the definition of motion. An object is in a motion when it change its position from initial to final. Means initial is denoted as, I will write in other pen, initial and final. Initial is denoted as U, final is denoted as V. So this you can write important point. So now next we will learn about, so note it down in your notebook, it is very important. So now next point is rest we can take. Okay, rest. Rest. We can take rest. Okay. So what is rest? An object is at rest if it does not change its, an object is at rest when it does not change its initial position. It does not change its initial position. Okay, so this is the main thing in this rest and motion. So write it down. So okay, this is the rest. Again in one place we will write it, motion. Now we will write motion. So what is a motion? An object change its position. I will make it short in with respect to its surrounding. So this is the definition of motion. Note it down in a proper way. Rest and motion. Okay. So now one thing we will learn that is the main in the rest or motion, and that is Rest and motion depends on observer. Rest and motion depends on observer. In downside we can, I will write rest or motion depends on observer. So this is the main thing. Read it down, read it, and opposed to this we will see one example. I will change the color. I will take red color. Okay. So now observe one thing. Let us consider this is a car. This is a car. Two friends are traveling in a car. One is sitting at point A and B. Point A and point B. And one another fellow there sitting down to the tree. He is C. So now you see the diagram properly. Now if you see the diagram properly, so now tell me one thing. Now tell me one thing. Let it go aside. Now I have a question. Now see, if I ask you a question, if I ask to see that A and B are in motion or not. If I ask a question to the C that A and B are in motion or not, so what the answer C will give, you have to write in your notebook or you have to send it in comment. So please send fast. I will count up to 3. 1, 2 and 3. So C will say that A and B are in motion. Yes. He will say yes. Why he will say yes? Because he is in a rest, but the car is moving and he thinks that according to his mindset that the A and B are also in the motion as compared to the car. So now if I will ask the same thing, now take it outside. If I ask a second question number 2 to A that B is in motion. I asked the question to A which is moving in the car. I asked two question to the A which is moving in the car that B, the friend sitting towards it, this is the B, this is the A, B, that B is in the motion or not. That B is in the motion or not. So what the answer will A give, you know? He will say no. Why he will say no? Because B is not in motion. The car is in motion. What he will say, B is not in the motion, the car is in the motion. Right? He will say same. Yes. So this is the main concept which you should learn it. So this thing over. So this over. So now tell me one thing. Keep it aside. Here we learn that rest and motion. Now next we will learn one thing. Now we will learn one thing next, that is reference point. Reference point. So what is the reference point? Can you define what is the reference point? Simple. The reference point is a origin. Okay. Reference point is also called as origin. And now here a definition of reference point. The reference point origin is a initial position of an object from where he or from where the object start motion. Object start the motion. So this is the definition of reference point, that a reference point is the origin, is an initial position of an object from where the object start the motion. Now I am at rest. This is my initial position and now I am moving. So this is my final position. Am I right? So that is the initial position. This is the final position. So that initial position from where I start the motion, that is the reference point. So that is the reference point. This is the main thing in this. You are clear? So now next we will move towards the keep it aside. And now let us, okay, next slide I have taken. Now what do we learn? Our motion over, rest over, reference point over, scalar, vector, physical quantities, so these topics we covered up to date. So now next we will learn about, now we will learn only two things, that is distance and displacement. That is distance and one is displacement. One is distance and one is displacement. Am I right? So take it as a side and move toward the writing. So first of all, this is the distance, this is the displacement. What is the distance? A distance is total path covered by an object. A displacement is the shortest path covered by an object from initial to final position. Okay, what is distance and what is displacement? A distance is a total path covered by an object, and the displacement is the shortest path covered by an object. So this is that these things. So what is distance? Distance क्या है? So take it aside, take a pen, write distance, displacement. So these two things I have written here. So distance is a scalar, this is a vector. Distance is scalar, displacement is vector. Okay. So these things we have to learn. Yes, distance cannot be negative, but this can be negative.